We're going to touch on some automation now, and this is probably a bit easier to visualise. It's a little bit closer to home for some. In automotive manufacturing and high-volume FMCG manufacturing, there's been traditional robots in place for the last 20 or 30 years. But there's a big development happening in this area, and I like to call it assistive robotics, where the robot's assisting people, or it's actually able to get closer to people. And we're very fortunate today with our friends from Flinders University, from the mechanical school, that they've been able to bring in one of their current pieces of automation to show. So I'll ask Craig to come up and give us a very quick demo of what this thing can do. Okay, so this robot is called Baxter. It was actually invented by an Australian who actually did his first degree at Flinders Uni, of all places. So there is a bit of a family connection here. Baxter is a robot of a new breed, and I guess one of the major disruptions that he brings is, one, it's very simple to program, and we can give some demonstrations of that, so that for those that are interested at the end of the session, if you'd like to learn more, Craig, I'm sure, can let you play with him and touch. It also doesn't need a robot cell, so if for example, a robot hits a person, if this was a normal industrial robot, it would be not good for me. But it's smart enough to know that something's wrong, and it stops, and it's got very sensitive sensing as a consequence. That opens the whole door up, especially for SMEs. I mean, a lot of the robot costs that are associated with automating like this are around the safety and the safety cell. A lot of the barriers for me to work next to a robot, making it safe, are very expensive as well. We don't have those problems with Baxter. The other really cool thing is that it has sensors in here, so it's got colour detection, it's got proximity sensing, it's aware of where I am, and so it's much friendlier, I guess, to interface with other things, and as a consequence, it's suitable for jobbing shops. So I might perhaps play the next video. This is a similar robot to Baxter, but in a current industrial application, and afterwards we can, at the end of this session, show a bit more of its capability with its sensing and what it can do. So this is for material handling. So if you had a robot application where you wanted to, for example, take parts off a conveyor, put them into a basket, sort by colour, sort by shape or something, this thing's smart enough to be able to do that. And we've still got lots of jobs that are at low volume that are necessary, but we know are expensive, or we don't run the night shift because it's too hard. This is the sort of thing that maybe could change that, and this next application can demonstrate that. Can we play Universal video, please?
We started looking at things that we could automate, simple and inexpensive, and so we started doing some research on, is there low-cost automation out there? And then we came across the universal robot. Well, one of the first jobs we looked at was a job that we were producing about 400 items of a particular valve, and we knew a new order was coming in for another 700 of those valves, and it was a monthly order. And we took a look at our capacity on the particular machine it was machining at. Without the robot, we would have been forced to buy another machine, even if we put a third shift on. After calculating the higher run rate using the robot, we realized we wouldn't have to buy another machine, and we even opened up another 30% capacity on the existing machine. We also then looked and said, well, where else can this robot go? So we looked at other smaller jobs, and that's what we were striving for the whole time, was to find a robot that was flexible, that could be moved quickly and programmed quickly and taken from machine to machine.
So if it moves to another job and then comes back, it's simply just taking the caps out, remounting the robot arm itself. Usually it's going to take us about 30 minutes to get it back in the ground and powered up. And then after that, it's just as simple as loading the previous project. Within the 45 minutes that we booted up the robot for the first time, we were testing safeties on it. So we had it using various accelerations and joint speeds. We had it running up against people's hands, just a firm stop in the robot, just to test to see how much force it would actually take to fail out the robot, which was really surprising for us because the robot's very sensitive to outside force. So we really like that, because it's one thing, again, to say that the robot can be used without guarding, but it's another to use it safely without guarding.
Well, so far we're looking for it to do simple jobs, simple tasks, that then we can take our current employees and continue to educate them to become the programmer of the robot, and or moving up doing quality control inspections of the parts coming off the machine that the robot's working on. Educate them more to become programming the CNC machines instead of just being machine operators.
I think another important message of moving up the value chain. So I think one of the things that Anthony didn't touch on today is with the tremendous growth of the business, the nearly 100 employees these days, but there's been a lot of automation put into Red Arc, but Red Arc's still employing people. They've just moved up the value chain. And I think the key message here is that automation is not about removing jobs, it's about lifting the value of what we do. Look, robots in production is one thing, but production need materials. And this next video, I think, will highlight, I guess, another area of disruption around assistive production and warehousing methods. Traditionally, they've been very expensive, they've been very inflexible, but this is obviously a higher volume area. This is a particular example is looking at some technology that was developed for Amazon, but absolutely this has got applications for SMEs in the future. So please run the next video, please.
This is video shot in our Northeast Quiet Center in Andover, Massachusetts, where we work 6 days a week across 2 shifts, often flexing to accommodate fluctuations in volume across any given week. This is our Kiva operation. You'll notice against the back wall are the dock doors, and then proximate to the dock doors are the Kiva workstations. For any given Kiva workstation, we can perform both outbound pick-pack functions as well as inbound replenishment functions, and it's terribly important to have that kind of flexibility. People often ask how the robots know where to go. You'll notice on the floor are 2x2 stickers that actually act as a guide for the robots, creating a map of the warehouse. One of the things that we really appreciate about Kiva is the ability to handle all different types of product across common infrastructure. We handle everything from guitar picks and jewelry to garment on hanger, different types of home goods, shoes, and again, it's all done across a common infrastructure, which is incredibly important for us from a capital perspective.
So I think everyone in the business will have some sort of material handling and storage, and even if you're just manufacturing something, you need to get parts to and from wherever you are. And the nice thing about this type of technology is that it gets rid of forklifts, and for those that know me, no, I don't like forklifts. They're the number one cause of worker injury in Australia. So there's some real safety benefits in a number of these things as well, because robots should be doing the things that we're not good at doing or could injure us. And we get secondary benefits, not just the improvements in productivity.